Hi, I'm Greg Lytle, VP of Engineering with Ozone Technologies. In this video, I'm going to demonstrate how you can be quickly up and running in less than 5 minutes with the DeepView Vision Starter Kit Micro. The DeepView Micro Vision Sensor is a highly integrated reference design which allows you to quickly prototype and validate your embedded vision design with edge-based machine learning. The microsensor is based on NXP's IMX-RT1064 processor, which is ideal for many IoT applications where a high level of integration, industrial interfaces, low power, and low cost are key to meeting your project goals. The Vision Sensor Micro is also fully supported with NXP's EIQ Toolkit, so you can use a GUI-based workflow to customize, train your machine learning model for your application. The platform is also ideal for evaluating Ozone's DeepView middleware, such as the Vision Pack for MCU-based image processing, the DeepView Model Pack for optimized MCU-based detection models, and the DeepView Application Pack for highly efficient object tracking. Now let's open up the kit and see what's inside. The DeepView Starter Kit includes everything you need to get up and running quickly. Here's the microvision sensor in its industrial aluminum enclosure, a 12-volt power supply with international adapters, a mini tripod for convenient mounting, a deck of playing cards so you can verify the included pre-trained model, a nanofit cable for accessing the I/O signals, and an Ethernet cable with an industrial IX connector on one end and standard RJ45 on the other. We've also included a convenient breakout board so you can access the I/O signals without having to build a custom cable. Here I'm mounting the microvision sensor on the tripod using a standard 1/4" mounting screw. Next, I'll connect a IX connector to an Ethernet cable I have going to my network. Then the nanofit cable is connected into the I/O connector on the rear terminal, and then plugged into our breakout board, which gives us access to power, RS-45, CAN bus, and some general purpose GPIO. Next, insert the RS-45 to USB adapter into the laptop, and the power supply into the breakout board.
I've switched laptops to make the display a little easier to see. Once I power on the sensor, you can see the boot up sequence shown on the console. Once the sensor finishes booting, you can enter Ethernet on the console to display the DHCP address that the camera has obtained. You can then enter this IP address into a standard web browser to display the live web page for the camera. Here you can see the live stream image. Now we've preloaded a detection model into the camera, which has been trained to detect playing cards. As I place playing cards in the field of view of the camera, both the location of the card and the value of the card is displayed. I can then move around the cards and the detection box is updated in real time, or you can switch cards and see that a new card has been detected. The web page also shows real-time statistics on the timing for the inference model on the camera, so you can get an accurate indication of how long a particular model takes to run on the sensor. This concludes the quick unboxing and demo of the DeepView Vision Sensor Micro. In the next video, we'll show how using the NXP Toolkit, you can quickly and easily reprogram the machine learning model and download it to the sensor without any embedded development. Thank you.